Hello, this is Clifford from Excel DNA. Today I'm looking at dynamic arrays in the context of Excel DNA add-ins and user-defined functions defined in such add-ins. Dynamic arrays is a very powerful new feature of Excel available in the Office 365 versions. And this is not an introduction to dynamic arrays. There are lots of those on the internet, and I'll post some links. This is really how dynamic arrays interact with Excel DNA. So let's have a look. This is the Excel DNA tutorials repository, and I've added a new topic here called dynamic arrays. So this has some links for background to dynamic arrays if you need an introduction, and then the discussion that I'm going to have now. It also includes the files for a sample add-in project, which includes the functions I will show. Okay, so let me open that project in Visual Studio. And the main file here is called example functions, and it has a bunch of functions we can play with a bit. Okay, let me start Excel and load the add-in, and then I'll open the example workbook. There we go, examples. Okay, so the add-in I've loaded, the sample project, has a bunch of functions that all start with the name DNA. And so DNA make array is one of the functions on this list, and there's a whole bunch of other ones, but they all have this same prefix, so they're easy to find. Okay, so dynamic arrays allows us to make functions that return an array, and as the size of the array that it returns changes, Excel will dynamically expand a spill range to contain that array. And so a simple function that returns such an array is the one I've made here called DNA make array, and it takes the number of rows and the number of columns, and it will return an array with some strings that contain like coordinates for the different cells. Because I've put 2 and 3 for the rows and columns, this is the size of the array it returns. If I made it 20 rows, it would make 20 rows and automatically resize. So you know that you're in a version of Excel that supports this kind of dynamic arrays, well, when it works like this, and when it's got the new functions like filter and sort. These are new functions that work with these dynamic arrays as well. And when I click on a dynamic array, it gets a little border around it and a shadow, and that tells me this is a dynamic array. Array functions don't get the curly braces that array functions in the past used to get. They are kind of anchored in this corner, top left corner cell, and then spill into the rest of the range, and Excel manages all of that perfectly. So this works great with our user-defined function that returns an array. There's no problem, and as we change the inputs, it changes the result size. If I make the input 1 by 1, it's a single value, and if I make the input 0 and try to return an array of 0 length, Excel will give hash value as the error. It doesn't know what to do with that. Okay, so that works perfectly, and everything is fine. Let's see if we take as input one of these dynamic arrays, whether that works okay. So the function I've made to show this is called DNA describe array, and it's just going to tell us how many rows and columns the input array has. And on this sheet, array input, I've used the built-in sequence function to get an array of the size with the rows and columns given. And so again, if I change the rows to 5, it will give me an array with 5 rows and 3 columns. And the equals DNA describe array can now be pointed at this anchor, this root cell, with a special hash added to show that we want the whole array that is spilled from there into our function. So now our function got an input with 5 rows and 3 columns. And if we change the number of columns here to 2, we'll see, okay, that changed in our function as well. And if we make the number of rows larger, it works like that. And we can even put a breakpoint on our project and just check if we recalculate this with maybe 3 columns. Okay, we can inspect the input array. We see it's the size we expect and it's got the entries we expect. Okay, so that all works fine. Array inputs work fine. I've made another function that takes an array input and returns an array. It's called DNA add prefix, and it will add a string prefix to every entry in an array. So suppose I pick my prefix is maybe something like an X with a space, and then I can use this function equals DNA add prefix to add that prefix to this array. Again, if I put the hash there, it spills into the right size. And so it's, as the input changes, my function gets the input and returns appropriately. So note that if I don't use the spill indicator here, then I can pick a smaller range out of that. But now it won't automatically resize because the smaller range will be not dynamic anymore. So even if I change now the number of columns or rows, this function is not changing in what input it gets. It needs to get the whole array, which is what the hash gives you. Okay, so Excel DNA functions can take arrays as input, dynamic arrays as input, and return arrays which are processed by Excel as dynamic arrays without any problem. So that's really nice and opens up lots of possibilities. You can imagine, for example, making functions that download tables of data from the internet, and there's no longer this problem of how do you actually get the right sized result, and all of that works perfectly fine. Where there are some surprises have to do with all user-defined functions, whether they take arrays as inputs or not. And so I'm going to show a little bit about this using a very simple function called DNA add them. I call it a normal function. And I'm just going to enter it in this Excel 365 as equals DNA add them, maybe 3 and 4, and it calculates and shows me a 7. Okay, so I want to show that this is actually behaving a little bit more strangely than we expect. If we move this workbook to an Excel 2016 or 19, which doesn't support dynamic arrays, and vice versa, if we put a formula like this into a workbook in Excel 2016, how does it come back into Excel 365? To help show that we're on which side we are, I've made a little function called DNA supports dynamic arrays, which just tells us is the current Excel one that supports dynamic arrays or not. Okay, so I'm going to save this sample workbook in this Excel 365, and I'm going to close it, and I'm going to open it in Excel 2016. So there's my examples, and I'm going to switch to a machine that's running Excel 2016, and it's got the same add-in loaded. It's exactly the same Excel DNA example add-in, but now I'm going to open this workbook here. And what I wanted to show you is that in Excel 2016, now we get the DNA add them has the curly braces added. And if I put equals DNA add them 5, 6 over here, and save it, you will see that it also shows a little bit differently on the other side. Okay, so it's more important than it looks by the face of it, and the whole topic has to do with what is called implicit intersection. Okay, so I'm going to save this workbook. So in this workbook, I've now just entered in Excel 2016 this formula as it is. I'm going to save it, I'm going to close it, and I'm going to take it across again. Maybe before I save it, let me just show you some. If I recalculate, let me see. If I recalculate this guy, I can see that we're in a version that does not support dynamic arrays. And even though our function has now come in as an array function, we will see that if we change the inputs, it does not dynamically resize the result. So the result stays an array function of that fixed size, no matter what the inputs are. So that's the behavior of shall I say, old Excel. If it doesn't have enough rows, it puts #NA into the extra rows. Okay, so I'm mainly going to focus on this issue of what happens to a simple user-defined function defined in VBA or in Excel DNA as we move workbooks back and forth. Okay, so I'm going to save this, I'm going to close it, and I'm going to move this workbook back to our Office 365 version. Overwriting the old one and opening it again in Excel. Okay. So now you can see that the functions that I've changed have gotten this added, and this is really the important one, is where it was entered in Excel 2016, that same workbook has this symbol added to it. That symbol is called the implicit intersection operator, and what that does is it changes how a function is used in certain contexts. So I've got an example sheet here that will show that story with the different contexts. So these numbers are just fixed numbers, and this function is called, this DNA add them function is called, but you'll remember DNA add them takes two doubles and returns a double. But when I call it in this way in Excel, where I actually pass it an array, Excel has to decide what to do. Is it going to take maybe the first entry of that array and pass that as the double? And in this case, a normally entered formula, that's exactly what Excel will now do. It takes the first entry, so I'm actually getting that this add them adds up to 12 because the first entry is 1 and 11, and they add up to 12. If I put an @ in front, then Excel is going to behave differently. Excel is going to say, okay, I've got an array as an input, but I'm taking a single value into my function. And then Excel will say, okay, can I take a corresponding row or a corresponding column from the parameters and use that as my input? And so with the @ in front, the same formula gives me a different result. It now uses the corresponding row and column to calculate. And the advantage of that is if I put this formula in all of the cells, it will calculate each cell correctly because it's doing this implicit intersection, and so it kind of behaves in this way where it's being well, I should have put the same formula there. I should have fixed the values. Okay, let me do that. I'm just going to fix the values and then copy and paste it across and down, and now it will do the right thing. There we go. So every cell is now looking at its corresponding row and column, and then those are the values that Excel passes to my function because I've got that Excel implicit intersection operator in place. So the reason for the strange behavior of functions getting curly braces in the one direction and @ symbols in the other direction is because of this implicit intersection. Excel is making sure that the default behavior in Excel 2016, which is with the @ is preserved when a function comes into new Excel 365. And likewise, when the behavior that is the default in Excel 365, which is without the implicit intersection, that is preserved by adding curly braces in the Excel 2016 situation. So if I go back to the Excel 2016 and I go to that same sheet with the implicit intersection, we don't have the @ in 2016, and it gives us the implicit intersection, whereas with curly braces we also get implicit intersection, which confuses me a little bit. I should enter it with Control-Shift-Enter. That's how it comes in from Excel 365 with curly braces as a array formula, and then it will take the first values in this special case. So Excel is going out of its way to make sure that the calculation is consistent between Excel 2016 or 2019 and Excel 365. But that means that the formulae are actually different. They look different in the two versions. In Excel 2016, you might have curly braces, and in Excel 365, you'll have the @ operator. Okay, so there's one more compatibility thing to know about in this regard, and that is what happens if you are using VBA to put a formula into your sheet or to read the formula. So I'm going to open this is Excel 365 again, and I'm going to open the VBA IDE, and I'm just going to go into the immediate window. And what I want to show you is that if we write a formula to a cell, it is sometimes a bit surprising. So if we say range, and I'll put a 11 dot formula equals DNA, add them 1, 2. Okay, so it's put the formula in, but it's put the @ in there. So it's doing the compatible thing, as if dot formula works in the way that Excel 2016 worked. And so any VBA or Excel DNA code that you have that is setting the formula will have the result of setting the implicit intersection operator there, again, so that the calculation is compatible. So let me change this, and I want to show you what they've added to Excel to get around this. There's a set of new properties called the Formula 2 properties that arranges have, and these are properties that don't make this formula conversion, and they're only present in Excel 365 where dynamic arrays are available. So if I put exactly the same formula here, you will now see there is no @ operator added. So over here now in A12 we have DNA add them without the @ operator, without implicit intersection. And so that formula 2 is the one that makes the difference between the compatible behavior, calculation behavior, and putting in the formula as if you typed it on the sheet, where it knows that it is a dynamic aware Excel. Okay, so that's something to look out for. There's some other stuff in the VBA side that is related to dynamic arrays. For example, if we look at, maybe I should go to this workbook, and this is cell B5. So if I say arrange B5 dot has spill, that tells us that is a cell which has a spill range, and we can also get the spill range associated with a particular cell. There's a spill parent and a spilling to range. There we go. Let me just say .address so it will show me something. Okay, it will tell me that's how it spills. If I go and change this again, I make it 5 rows maybe. I expect that this spilling to range will now change. Yes, it has. It's now C9. Okay, so there are some properties added to range related to this whole dynamic arrays and spilling that you can then use to explore. You can also get, I think, the spill parent of a cell. So if you know that this cell, C7, you can check whether it is part of a spill range by saying C7 dot spill parent dot address or select or something. And so there's the link between these spilled cells and their spill parent and the range is all available inside the COM object model, which you can use from VBA or from macros in an Excel DNA add-in. Okay, so that's some of the story about implicit intersection and how things work between different Excel versions. The final thing, or one of the last things I want to show you, is that if we have a simple function like DNA add them, we can now make, let's see where it is. I will come back to the async one. We can make an array function out of a function that is not an array function with this magic DNA array map 2, and it will take an input so it takes as input the function name without brackets and then the arrays, and it will apply each value in these arrays to that function and then return the whole thing as an array. So this is calling DNA add them for every entry in the first array and every entry in the second array, and that's how we get this array grid out of a function DNA add them, which does not know about dynamic arrays at all. So DNA array map 2 is one of the functions in this example in the array map class. I'm not going to talk about it more here, but it is part of this example project. Okay, the last thing I just want to show you then is that asynchronous functions also work fine with these dynamic arrays. And so DNA make array async takes a delay and then a number of rows and columns. That's a spelling mistake. Dynamic arrays. Okay, so it takes a delay, maybe 5 seconds. I'll take 3 rows and 4 columns, and then I'm gonna call the DNA make array async with the different input parameters. And now we expect to wait a few seconds, and then it will come back with the right array result. And again, as we change the inputs, we expect every time it's like it's fetching now from a back-end system or something, and the result comes in asynchronously. So in the past, it was problematic to make asynchronous functions that are array functions. They didn't always work right, and the old array resizer example that I made didn't work well with asynchronous functions. But for dynamic array Excel, asynchronous functions and streaming functions and RTD based functions all work perfectly well with array results and array inputs And so that's really a great advantage of dynamic arrays Excel. Okay, I hope that has given you some idea of how add-in functions and UDF functions interact with the dynamic arrays feature in new versions of Excel. It's a really great feature. It works really well with add-ins, but there are some things to know about if you are a user or in an environment where there is a mixture of dynamic array supporting versions of Excel and older versions of Excel. If you have any questions or any thoughts about this, please post a comment. I will put some links into the description as well. That's it for today. Thank you very much.